Hey, what's going on, guys? Xiangqi here. In this video we're going to be making some perf testing. So perf, also known as performance test, is the way to do at very least two things. So the first is to make sure that the move generator is bug free, and the second, we can measure the speed of our move generator, which dramatically affects the plane strength, believe it or not, of the chess engine, because the faster engine we have, the stronger we place. Well, actually, the matter of fast search is the matter of how good you would optimize the alphabet search itself, but the fast move generator is something that is very crucial regarding so-called nodes per second parameter, which is one of the important parameters to measure the speed and actually the strength as well of a chess engines. So let's say we have exactly the same searches, but one mode generator is around 5-6 times faster than another, then we would have around 150 elo points difference. Well, at least that's the experience with my JavaScript chess engine of International Western Chess, Wukong.js. That's the experience I had. So that's kind of it. Okay, guys, so just in order to avoid wasting your time, and bear in mind that the perf code is very trivial, I will just simply paste a couple of functions here to our source code, and would rather go for explanations regarding how the stuff works, and that's the way to go, basically. So the first thing to consider is there's golden data I have obtained, so the results for perf test. So a few words regarding these tables. This was incredibly difficult to come up with this value. So first of all, I had not precise values. The second issue that I was using the buggy engine to, not the engine, but JavaScript library, Xiangqi, which had some bugs, so it only did pass the first two nodes, and then it was just given the crap results that didn't reflect the actual numbers of nodes to be traversed. And also, in the International Western Chess, there is the position called key repeat, and it's also known as a tricky position, which captures the most bugs of the mode generator. And I was wondering if there is some sort of a similar FEN, some sort of a position in the FEN representation like we have here. By the way, it's actually good to give the entire FEN to not confuse the parse FEN function. So I'll show you how this looks like. So we have the values for this one as well. I'm very sorry that I'm not giving credit to a guy from whose GitHub repos README file I've grabbed this, but I just only remember that there wasn't any engines, and everything within the README was in Chinese. But Google Translate helped me, so he had these values there, and also some theoretical explanations. I didn't really read through them, but this data is absolutely essential. So thanks to some Chinese guys, I don't know his name, but I really appreciate for this. I swear I was trying to find that again, but I couldn't, believe it or not. I don't remember how I was searching for that. I found that eventually, accidentally. So yeah, and I was also using the engine Chameleon by Ether Cyber. That's not the name, but just the nickname for GitHub, and I use that to actually check these values. So a real-world CNC engine derived from Stockfish 7, so that definitely should be something solid, and it did pass the perf test for both positions with exactly this sort of values, which means that we can fully rely on these values for our perf testing. And I was calibrating my engine using that Chameleon engine. So if you want to know a bit more information about how exactly I was debugging the mode generator, there were only a couple of bugs, like in canon captures and in the bishop mode. So bishop wasn't blocked by the piece. Now it is, obviously. So if you're interested how I was debugging the mood generator, just feel free to watch the video, not the previous, but one before the previous. It's called Bug Alert in Generate Moves. So I gave a couple of examples of debugging techniques I've been using to come up with this proper results. Okay, so now we'll simply grab these perf functions. So I'll probably just, well, let's start with this one. So I just want to copy and want to paste this right over in here. And also one little thing to consider is, well, actually want the nodes to be the part of the of already the next kind of part, which would be the search. Also we would be having the evaluation as well, but on the other hand we might not be doing that, so it's a little bit hard to say. No, it's better to, so we would also be having search and evaluation, but before that we would be dealing with the Zobrist hashing to give this unique position identifiers for every single position to avoid repetitions, and especially perpetual checks, which is absolutely crucial in Xiangqi. Okay, and before search we would also have the evaluation, but yeah, it's just, can drop this for now, or can paste this, but yeah. Okay, so something like this. Okay, so nodes would be leaving here because it's more like something that regards to search. I hope the scope for the nodes is still okay. And here is the perf driver. So this one doesn't print any results like I've been showing before. It's just the driver, it's not the tester. Well, you'll see the difference. The tester actually runs from the root, and for every root node it calls the perf driver. That's the difference. So here I have command code to show you how the mood generator actually works in terms of making and unmaking moves. So what's going on under the hood? So I just comment out this sort of stuff here, and we'll now go to the initial position. Where is the initial position? This one. Okay, so we'll print the board, and then we just call this perf driver. And well, let's start with the depth 1 just to give you an idea how it works. Okay, so if I update the stuff, so it already interrupt the user input. So you see like this pawn has been moved, so moving every single pawn then moves the cannon. If I just speed up things a little bit, you see like it's making all the moves, and when it's done it's just over. But it was only depth 1, but we obviously want to search deeper. So let's say in the depth 2 this would be looking the following way. So we just made a move, and then we made this pawn move, then we're responding with all the black pieces we have there. Okay, and then we made another move, this pawn, you see like then it would be this pawn when all the black pieces are done, and so on. And every time the position like this, whatever position we encounter, we calculate the nodes, we count the nodes, and the summary of those nodes, so it's like this pawn now goes, the summary of those nodes is the matter of measuring the accuracy of the mood generator. So that's how it works. But obviously nobody does this like this. I just wanted to show you the concept, because for me personally it's very fun to watch how this stuff works, and it's literally enough for us to have this sort of a perf. And how to pre-print the information regarding the old nodes for every single move. That's incredibly useful for debugging purposes, and also to see how long does it take to complete the perf test. We use this sort of a function which is called perf test. So okay, now so yeah, we reset the nodes every time we come here. That's needed in order to, if we run perf test several times in the row, the nodes are getting resetted properly. So that's very important. Then we need to know the current time Then we generate moves, loop over the moves. Then if move is illegal, in example, it's actually gonna, in case if the king is left exposed into a check, which is continuous, so we're not counting this. Then we're calculating the cumulative nodes, then calling the perf driver recursively, taken back, then calculating the old nodes via subtracting cumulative nodes from the overall nodes we have here that are being populated by the perf itself. So this is where it happens. And then we just print some stats and basically we're done. So very simple. So now instead of the perf driver, let's go for a perf test. And if I have copy pasted everything correctly during the previous couple of videos, then in that case we should be obtaining exactly this sort of a, oh my god, where are them? This sort of a numbers. Okay, so perf. Let's start with the perf 1, perf test, save, and yeah, I just need to restart this, for otherwise it would last kind of too long. I don't want to manually go through all of the moves. And here should be 44 moves. So here is the initial position we're running perf test to. So just made move and kind of took back 42 nodes, exactly the number that we have here for starting position. So the depth 2 should be 1920. So let's try this depth 2. Well, we could do this in the loop, but yeah, I'll probably show this manually. So we have this 1930. Okay, now depth 3. Okay, 79666, exactly the number we need. Now let's go 4. This would be slightly bit longer, so let's go perf 4. Bear in mind that the video recording software is working on my machine. This is going slightly longer compared to if this software doesn't work, but still. So this is around the speed of my International Western Chess Engine Okun. That is also written in JavaScript, so it's about equal speed. So 3 millions 2902. So okay, 332 90 24 0. So let's compare. So 32 90 24 0. Now 1333 and so on. So this would take a little bit longer. So I will probably not be running that. I swear that works. You would be able to try this on your own, but this just takes a little bit too long. So around, I don't know, maybe 20 seconds or even more, maybe 30 seconds. Just don't really want to wait for that. So now instead, let's take another test in position and drop back to perf 1. So it should be given 38 for us. So perf 1, and now I want this position to set up manually. Okay, like this, and we just run it. So we have 38 moves, and this is the position. So it's quite pretty tricky, as you might see, many cannons. So if rook goes here, then king would be exposed into a check. Hence this move, rook from f3 to e3, sorry, is illegal. Okay, sorry guys. And so far and so on. By the way, the bishop bug I've revealed thankfully to this position. So I had the move of bishop going from e7 to f9 to g9, ignoring this knight, blocking the bishop. But thankfully to Chameleon Chess Engine, and thankfully to this perf test results also, and thankfully to this position, I managed to figure that out quite pretty quickly, and fortunately to fix that. So let's go perf depth 2 and update 1128. So 1128. You know, like this is the most pleasing thing when you're doing chess programming, when you pass in the perf test. This is probably one of the most amazing things ever. So let me just prettify the layout slightly a little bit here. Okay, so the next should be 43929, 43929, 43929, perfect, and depth 4, and we have 1339047. So 1339047, and same for this. I ran this one and I ran this one. I didn't run this one because this kind of takes a little bit of ages, but I really tried that this should be fine as well, because again, like, this is just a matter of experience. So this is it, guys. This is it regarding the bug-free move generator, believe it or not, and this is the pivot point in the entire chess engine development. So the next, let's overview a few next steps that we're supposed to be doing within this series. So the next would be to implement this arborist hashing. I think we'll go within this format of me just copy pasting the code that I've created and just talking through, explaining through. Also, just bearing in mind the fact that I already have that code in my Wukong.js chess engine, so no really need to rewrite that code. So yeah, I think that just totally fine to bring that in, and maybe I would even be doing that in live mode, but yeah, probably I would be tempted to test that first and then just cover through how it works. So we would be adding some code into the make move and the take back functions. So first, within the make move and take back, every time we're moving a piece or adding new piece on a board, like in case of the captures, or taking this away, like capture make move or capture take back, restoring the piece, we will be using XOR operator with its perfect nature of adding and removing the numbers and removing pieces into the single given hash key, and that's the way to incrementally update this unique position identifier, also known as position key or hash key. So that's kind of it, and we would be using that to, again, like as I was mentioning already, just to detect the repetitions, like threefold repetitions, and that should be used for perpetual checks as well. I'm not sure yet how exactly that is implemented. I need to have some consultations and talk chess from guys who has already done that before. But anyway, and also regarding the search, we would be keeping track of 3 variables. So search ply, which is the search ply, nothing much, from the root search and then to the leaf nodes. Then the game ply, then historical kind of ply of the game, and also the repetition table that we would be writing current given hash key to. So later on we would be able to reference that repetition table to make sure to actually figure out whether the repetition has occurred during the game or not, because that's absolutely crucial stuff. And as soon as that would be done, we will then be able to move to the evaluation and search. I'm not sure how exactly the evaluation would be done, but the general approach, the general concept of having simply like material and p-square tables should be literally enough for the very first implementation at the very least. So that's something that can be later on improved more and more. The entire alphabet search, I would try to reuse the alphabet search from my Wukong chess engine, because that's the best optimized alphabet search I have so far. The only thing to change there would be to reinitialize the MVV-LVA table, the most valuable victim, least valuable attacker. Yeah, so that's the way to go. And all the rest, including the collecting the principal variation, so all the stuff like search optimization techniques like null move pruning, razoring, evaluation pruning, what else, hash table, what else, late move reduction, principal variation search, all those techniques are already bundled into the search, so I don't see much reason on changing that. So the only thing that would be changed is the logic of stalemate and checkmate. So we're not going to be distinguishing like stalemate as a draw. Instead there would be. So if we have no legal moves, there would be returning the mating score for both stalemate and the checkmate, no matter whether the king is in check or not, because in CNC that's the game. So stalemate is also a win. So yeah, that's the plan, guys. That's the plan. And then really lots of work to be done, and I didn't yet take a decision of how I'm supposed to be proceeding regarding connecting to the GUI. So whether we start with implementing our own GUI, the web-based, again, like that would be heavily reused from Mukun.js. I just need to bring in new textures for a board and slightly well change that a little bit. But anyway, I think this format is the most appropriate, because not much of a sense watching me type in the code. If you want to watch me type in the code, you just have a look at my Bitboard Chess Engine in C series, where I was typing literally all the code by hands. But I was doing that because I've done lots of chess engines before that, so around 5 or 6 chess engines before that. So that's why I was doing this. And here, this is the very first CNC engine in my life, so I just can't really go for this live coding experiments, because accuracy is above all. Okay guys, so this is it from my side. I hope you enjoyed the video and learned something interesting out of it. So until the next time, and take care.